Hey everyone, my name is Anvita Bansal and we are back with another lecture based on linked list. So the question that we will be discussing today is nth node from end of linked list. Let me just check if we are live. Yeah, we are. Okay, so let's move on to the problem statement. So given a linked list consisting of L nodes and a given number n, your task is to find the nth node from end of the linked list. Okay, so let's directly move to this board and I'll tell you. Okay, so there's a linked list. 1 second. 1, 2, 3, 4, 5, 6. For example, this is your given linked list. And n that I give you is 3. Okay, so you have to simply return me the node, precisely its data, which is third last in your linked list. So the third last node from in this linked list will be, this is the last, second last, third last. So this is what you need to return. Okay, for example, if I say n is equal to 2, so the second node from the end of the linked list is what? 5. So you need to return 5. If I say n equal to 4, then you have to return fourth node from the end of your linked list. 1, 2, 3, 4. Okay, and if I say what is the length of your linked list? 6. If I say n equal to 7, that means there will be no node which is at 7th position from the end of your linked list. In that case, you will return -1. Fine. I hope the question is clear to you. Now, what are the ways to solve this problem? Now, you must be thinking, why is it even a question? The reason being that in linked list, this is a single linked list in which we have address of the next node only. Okay, can you traverse to your previous node until unless you take some pointer or another variable, temp pointer, anything which is actually pointing to the previous node? But is there any way that you can traverse from the end of your linked list and get the address of the previous node? That means, for example, you are at 6, can you get address of 5 with just a variable pointing to 6? No, that's not possible. It's a linked list. So how can we do it? The brute force approach, or not even brute force approach, the possible approach could be that you first go ahead and calculate the entire length of this linked list. Okay, what is the length of your linked list? You traverse and find it is 6. Now what you need to do is 6 minus, let's say your n that I give you is 2. Okay, 6 minus 2 is what? 4. Just tell me one thing. The second node from end of linked list will be which node from the beginning of your linked list? N minus L, length minus n plus 1. That is length minus given n plus 1. Then what you need to do is, first you calculate the entire length of your linked list. Then you figure this thing out that from the beginning, if you come at or traverse at the length minus n plus 1th node, that is exactly the node that you should be returning. That thing is easy, that can be easily done. So first, second, third, fourth, fifth node from the beginning is the one that you need to return. So we are just doing a other way around. We just calculated the length. By first traversal we calculated the length. In second traversal we are moving to length minus n plus 1th node. Our loop will go until our let's say I becomes equal to this index. If you're starting from 0, then you have to obviously take care that it should be 1 less than this position. Okay, so this thing can be done. Now the problem is that, okay, first you are calculating length and then you are traversing to this. Is there any other way in which we do not have to traverse through the linked list again? You're getting this thing? Can we do it in one pass? Yes, we can do it. So this solution is also very easy. What we are going to do here is that we are going to take 2 pointers. Okay, the only trick part is that how are you going to take these 2 pointers and which position do you want them to, so that you get the required result. So now let's have a look at this thing. For example, again we have 1 pointing to 2, 3, 4, 5, 6, and it's pointing to null. Fine, this is your given linked list. What am I saying now is that, and let's say n equal to 3. So my idea behind using 2 pointers is going to be that you take the gap of exactly 3 nodes between your 2 pointers, so that when the first pointer, the pointer that is ahead of the previous pointer, when it reaches null, it will be at the previous pointer will be behind this pointer by exactly n nodes. So that way we can have the address of third node from the end of your linked list. We'll see how that is going to work. Let's say I have a node current and I have a node previous. Both are initially pointing to head. Now what I'm trying to do is that you go ahead in this linked list and traverse until you reach which node? You reach this third node. For example, you're moving your current at this position, then you moved your current at this position. Now you're moving your current at this position. N equal to 3 for how many times? For example, n was equal to 2, let's say, smaller example. So my idea behind this is that bring your current pointer 2 nodes ahead from its current node. Okay, so when you bring it to, basically you have to run a loop which goes and brings your current pointer to the 2 nodes ahead from the current node. So now let's say my current is pointing to this node. Okay, fine. Now what? You can see there's a gap between previous and current by how many nodes? 1, 2, right? Now let's have a look. Keep doing this iteration unless current becomes equal to null. Okay, then you see where is your previous going to point at. So the intuition behind this is the node that you want to get from the end of your linked list. Create that gap between 2 pointers that you are taking. Now let's see. In the next iteration, previous will be here, current will be here. Next iteration, previous comes here, current goes here. Next iteration, previous comes here and current goes here. Okay, now in the next iteration, current will be pointing to null and previous will be pointing to this node. Okay, so next iteration, current becomes null and previous is pointing to 5th node. Now stop. When your current becomes equal to null, where is your previous pointing to? It is pointing to node number, this node whose data is 5, and we wanted second node from the end of your linked list. So isn't previous pointer present exactly at the node whose data we want? So that was the idea, that you create a gap of n equal to n nodes between your previous and the current pointer, so that when your current pointer points to null, your previous will be exactly pointing to the nth node from the end of the linked list. That's pretty much about it. Got it? Now one case that you should be taking care of is that, for example, I give n equal to 6 itself. What is the length of your linked list? 6. And I am giving you n equal to 6. That means you have to tell me the node which is at 6th position from the end of your linked list. So that will be your head node itself, right? This node itself. And if I keep on doing the same thing for previous and current, because initially my previous and current both are pointing to head node. Now what I'm trying to do, I'm trying to create a gap. I'll be making my current node point to that node such that the difference of nodes between previous and current will be of total 6. But that way my current will come at null. 1, 2, 3, 4, 5, 6. It will come to null because it is already at head. Now what you're going to do? Previous, I'll show you in the example. In that case, what we were doing, we were creating this gap. Maybe current will come here, then you'll start moving. In that case, you won't be able to fetch the exact head of your linked list. So this case, let me just write the code, then when I'll add the condition, I'll come up on how to do it. Okay, so let's just, I hope you understood this. Basically, we're going to take two pointers and create the difference of n nodes between them, and then we'll do the iteration until your current node reaches the end of your linked list, right? So let me just write the code for the same. Just take care that we are going to handle this case. Now how? I'll show you first without adding the condition for it, so that you can see for which case it is failing. Fine, let me bring it to your, okay, so let's have a look here. Node current is pointing to head, fine. Then we have node previous, let's say it is pointing to head again. Now take a loop. Let's take int I is, let me start my index from 1 for the just for the ease of understanding where it is going to point at. Now while, what do I want? I want my current pointer to be ahead of previous pointer by exactly n nodes, right? So let me, it is already at head. So while I is less than or equal to n, bring your current to current.next, okay, and do a I plus plus. Fine. Is that okay? Fine. Now one important thing to note here is, for example, this is your test case in which n is greater than the length of your linked list. That means you will keep moving your current. N is what? In this case, n is 5 and the length is 4. So in that case, when you will keep running your loop, current will point to null. Before this loop ends, before this loop terminates, current will be pointing to null. And then you will be again trying to do current.next. So that thing, in order to handle that case, let's put up a condition. If current is equal to null, that means we have reached the end of the linked list and we do not have a node. N doesn't lie within the range of the length of your linked list. So we should be returning -1. I hope you got this point. Fine. Okay. So I have put this condition right here. Now, I'm sorry, not here. Let us put it here, because after doing current.next, if we find it to be null, return -1. Okay. Coming out of this loop, now what you have to do? Do the simple iterations until your current becomes equal to null. What you are doing? You are simply doing current.next and doing previous equal to previous.next. I'm sorry, previous equal to previous.next. Fine. What is it going to be while current is not equal to null? Fine. Now what? Now when you come out of this loop, ideally your previous should be pointing to the node that we want to return. Now this solution will fail for few test cases. What are those going to be? First let's see, and then I will add up the condition. Okay, so let me just check. Sorry. It should be previous dot data. The return type is int, so it will fail. The return type is int, so we have to return the data. See, it ran for this case, but let's see for what it fails. Then I will add up the condition, because you will also miss this condition if you don't go through where it fails. So see, 1 2 3 4 5. Now it is failing for this condition, the one I was pointing out to. Why is it failing? Because let's just write this case 23 89 50. We can take anything and let it be 5 5. Okay, I'll just show you. This was your code, right? Let's see why it failed when for such a test case. So our test case was something like this. I'm not writing the exact test case. We're just writing the similar condition, which is 1 pointing to 2, pointing to 3, pointing to 4, pointing to 5. Now n is 5. Length is also 5. It is expecting us to find the fifth node from the end of the linked list. So this is the end, first, second, third, fourth, fifth. This should be returned. 1 should be returned. Let's see why is it failing. My current initially is pointing to head. My previous is initially pointing to head. Now for I equal to 1, okay, you initialize I1. Current becomes current.next until I is equal to n is what? 5. I initially is 1. Now let's start our loop. Current is pointing here and I is now 2. Right, I is 2, fine. For next loop, current comes here and I becomes 3. Next current comes here, I becomes 4. Next current comes here, I becomes 5. Fine. Now what? I becomes 5. While I is it is still less than n, current will point to null, right? Because when I is equal to 5, it is still equal to n, so now my current will be pointing to null, right? Now when you try to do I plus plus, you will come out of the loop. Now what? See, although what is the case here, why my answer is returning me why my solution is returning me -1, when I was equal to 5, you went inside the loop, you did a current dot next, and you came at null. Now due to this condition, current is null, you are returning -1. But our intention was that current should be null only when you have already reached the length, means you already this is with the intention that what if I itself or given n is greater than the length of your linked list. But in this case, the issue is we have come to null and previous is still pointing to head. So ideally, when we try to follow this loop, I should be returning previous's data. But this condition is returning me -1. So I have to put a check here. If my I, and what was the I in that case? I was equal to 5. That is okay. I have to check that if my current is equal to null, correct? I should be returning head dot data straight away. I should be knowing that in the first iteration itself, in this first iteration means in the first while loop itself, if my current is pointing to null, that means they are expecting me to return the head node at which the previous is pointing. Okay, so there are two modifications that we need to do. One is that in this condition, if current is equal to null and also your I is not equal to n, you getting my point? That means your n was greater and I has still not reached there, and you have come out of, and current has become equal to null. That means the length of linked list was smaller than given n. So you should make sure, let's write this condition here, if current is equal to null and I is still not equal to n, got it? Then you are returning -1. So in that case, you will not hit this condition, and when you come out of this loop, you have to check now if my current is null. That means they are expecting me to return the first node of the linked list. Return head. Now let's check. Head dot data. Got it? So you can handle it on your own. I just wanted to put forth that this condition should be taken care of. If not, then you might end up getting test cases failed. So it's up to you how you want to handle it. I hope the intuition and the solution is clear to you. If you guys have any doubts, you can ask me in the chat. Otherwise, that is all for today. Let me just see if you guys have any doubts. Fine, then that was all for today, guys. See you all in the next lecture. Bye bye and take care.